Okay, for 7.5, we're looking at indirect measurement. We can't measure something because it's too tall, it's an awkward shape. So what we can do is we can use methods that incorporate formulas or similar figures, which we've been studying, proportions, which happen to deal with similar figures, right triangles to measure an object. So in this situation, we have a student who wanted to find the height of a statue of a pineapple. But she measured the pineapple shadow and she measured her own. So locating the center, she was able to create a right triangle and find from the center the length out, and we measured it at 8 feet 9 inches. She also measured her shadow, which is 2 feet. She knew her height was 5 feet 4 inches. So what is the height of the pineapple? So what I'm going to use now is my tools. It gives me a hint here and it says convert the measurement to inches and are the triangles similar. So I'm going to use this, but I'm going to finish reading the problem first. It says are the triangles similar? Well, she's standing at a 90-degree angle to the ground, and this triangle is also located at a 90-degree angle to the ground. So I have one equal angle here, which is the right angle. And then I also have a second equal angle because the sun's rays are parallel. We have this line here and this line here are creating the same angle for 1 and 2. So now I have angle, angle. Two angles matching. We know that these two triangles are similar. Okay, so I start by converting and using my hint, make everything measurements to inches. So 12 inches in 1 foot. So her shadow is 2 feet. So 2 feet times 12 inches will give me 24 inches. The pineapple shadow is 8 feet 9 inches. So 8 times 12 plus the 9 inches. So I get 96 inches plus 9 inches. So I'm at 105 inches for the pineapple shadow. And then I have her height is 5 feet 4 inches. So 5 times 12 plus the 4 inches. So I have 60 plus the 4, so I have 64 inches. So now I'm just going to set it up as a big to little, ratio of big to little. So I'm looking at the big shadow is 105 inches to the little shadow, which is 24. And the actual height is a mystery here. We don't know, but we do know her height. So we have 64. Okay, I'm going to cross multiply 105 times 64. I'm going to plug it in my calculator, and 105 times 64 equals 24 times x. I have to solve for my unknown, so divide by 24. Divide by 24, and I plug it into my calculator. This goes away. So now I have x equals the answer of 105 times 64 divided by 24. Okay, so x came out, it's 280 inches, and then my last thing I want to do is I want to convert that to 80 and divide it by 12 so I can figure out in inches and feet. So 280 divide by 12, and I get that's 23 feet, pretty tall pineapple statue, and I've got 0.333 on my calculator. So what I'm going to do is 23 times 12 gave me a 276. So 23 feet is 276 inches. And I have 280 inches, so I have 23 feet, and I have 4 inches left over. So our pineapple statue is 23 inches, and 23 feet and 4 inches.
A scale model or drawing is used to represent an object that is too large or too small to be drawn or built at actual size. The scale gives the ratio of the measurements in the model or drawing to the measurements of the actual object.
For the next example on 7.5, we have a scale drawing. And in this situation, we have a map, which is representing a larger area. And so a scale drawing can represent an object that's smaller or larger. And this drawing has a scale factor, which we call K, and that represents the drawing length over the actual length. So when you do that, you'll create a multiplier. And in this situation, the scale of the map of downtown Dallas is 1.5 centimeters to 300 meters. So if we measured a distance of 1.5, and in this is our 1.5 centimeters, this 1.5 centimeters would equal 300 meters. If we had a distance that was 3 centimeters, 3 centimeters would be 600. If you had 4.5 centimeters, you would have 900 meters, and so on. So what they'd like to know is the distance between the Union Station, which is over here. I'm going to highlight it for you real quick. So here's the Union Station and the Dallas Public Library. So what we need to do is we need to actually find a way to measure this area right here, and that would be our drawing length, and then we would be able to find out the actual length. Okay, so what we do is we look for our K, and we plug in 1.5, which is the drawing length, divided by 300 meters, and that gives us a 0.005 ratio of drawing to actual. And then what I did was I measured this. So this is our 1.5 centimeters, and I measured from the Union Station to the Dallas Public Library, and I got 5.5 centimeters. So now that I know my K, I can plug it into a couple different ways. A lot of people will say, okay, I know what K is. So K is my drawing to my actual. So I could plug it in 0.5 equals my drawing 5.5. Ooh, this is tough. Divided by unknown. This is what I'm trying to figure out, the actual. When you do it like this, your x is on the bottom, so you need to multiply by x to get rid of it being on the bottom times x. So that gets rid of this. So now you have x times 0.005 equals 5.5. So then divide by 0.005. Divide by 0.005. So x equals 1100 meters. Alternative ways to do this are you could also do a ratio drawing length to actual, drawing length to actual. So you could also, just an alternative, so that's one option. Here's the answer, 1100 meters. But the alternative option is you can say, okay, 300 is my drawing length, my actual, over 1.5, which is my drawing, is going to equal 5.5 over unknown. It's going to work out the same way and then you will just go through and cross multiply if that's what you like to do, and sometimes that's more fun. So you have 1.5x equals 5.5 times 300. You're going to divide by the 1.5. So you can get rid of it. Divide by 1.5. Gets rid of the 1.5 here. So now you have x equals 5.5 times 300 divided by 1.5, which will also give you 1100 meters. So there's a couple different options. Again, this is just a little to big, little to big, little to big, little to big, little to big. So as long as you set your ratios up so that the littles are lined up and the bigs are lined up, or you can put big to little, big to little. There's several ways you can solve this one. And this is the last example for 7.5, and we're talking again about the similarity ratio, little to big ratios between two figures A and B. And so we're going to label this, it'll be our figure A, so this is the little guy, and this is figure B. So then the ratio of their perimeters will also be A to B, and the ratio of their areas will be A over B squared, or again, you can use this and distribute this to both sides with the exponent. So that's A squared over B squared. So given that triangle LMN is similar to triangle QRS, they'd like us to find the perimeter P and the area of this QRS. So what we've been given is, we have to look at what we've been given so we can kind of make a plan. And right now we've been given the lengths of similar sides. So L is similar to Q. So that's important to know. You want to know direction with triangles. And then you have M is similar to R, and so M is similar to R, and we have N is similar to S. So this one is similar to this one. So that means it'll flow in the same direction. This is going to be similar to this right here. LM is the same as QR because they have the red to blue, red to blue. And so we've been given some general sides right here, and we know that red to blue, so we have matching sides. So this 9.1 and this 13 are somehow a ratio of each other. So what I did was I figured out that I need to set up an equation for K. K is little to big. So I have the little side to the big side. When I'm talking about little to big, I'm talking about the little shape to the big shape. And I have a little perimeter to a big perimeter, but I don't know the little perimeter. So when I've set it up like this, I just create a cross product, and I have, I'm going to use a different color. These guys equal these guys. So 9.1 times 36 equals 13 times x. Now I've got to isolate my variables, so I'm going to divide both sides by 13, divide by 13, divide this side by 13, 13 gets rid of this, And so plug it in my calculator. 9.1 times 36 divide by 13, and I get 25.2. So x equals 25.2. I'm sorry, this is so hard to read. It's hard to write with this pen. Okay, 25.2. So my small perimeter for this guy is, I'll type it, perimeter equals 25.2. So now the last step that I need to do is I need to find my area. Now area is going to be a little more complicated because I'm going to square it, but I can make this really simple. Okay, so what I did was I just remembered that I'm still using a scale factor little to big, but now what I'm going to do is I'm going to use this little to big and I'm squaring it. So little to big squared equals x over 60. So 9.1 divided by 13 is 0.7, and that's squared equals x over 60. So I solve for my unknown. 0.7 squared is 0.49, and to get rid of the 60 on bottom down here, I have to multiply it times 60, multiply this times 60, and that gets rid of this. So now I have x equals 0.49 times 60. And that equals times 60, 29.4. So 29.4. So my final answers were, I had perimeter equaled 25.2 centimeters and area of shape 2 equaled 29.4 centimeters, and then there's a little square, so that's kind of hard to do with this, but I'll put little up 2. And that's my final answer. Thanks so much.